Our video project is on finding the interval of convergence of a power series using the ratio test. To begin with, we're going to explain what a power series is in case you don't know. It's basically an infinite series in the form of the summation from n equals 0 to infinity of a sub n times x to the n, where n is always going to be positive.
The ratio test is a type of series test, and the form of this is as the limit of n approaches infinity of the absolute value of a sub n plus 1 over a sub n.
The interval of convergence is the set of points on which the series converges. Okay, now let's do an example problem. We have the summation from n equals 1 to infinity of x to the n over n. So to review, we know that for the ratio test, we're going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Okay, in case you were wondering, if you are dividing by a sub n, it's the same thing as multiplying by the reciprocal of a sub n, which is what we're going to do later in this problem. So instead of dividing by x to the n over n, we're going to multiply by n over x to the n. Okay, let's plug into our formula. So we have the limit as n approaches infinity of x to the n plus 1 instead of x to the n over n plus 1 instead of n. So basically all we did was plug in n plus 1 wherever we saw an n. And then we multiply by the reciprocal of a sub n. So we're multiplying by n over x to the n.
Okay, so now we have the limit as n approaches infinity of the absolute value of x to the 1 times x to the n over n plus 1 times n over x to the n. You might be wondering how we got x to the 1 times x to the n. We did this using fundamental exponential rules. Now it is easier to see that the x to the n cancels.
Okay, now that we've canceled the x to the n terms, we're left with the limit as n approaches infinity of the absolute value of x times n over n plus 1. So I've isolated the x term because whenever you're performing the ratio test, you're going to want to pull out your x term to the front of the equation in order to separate it from the n terms. So by isolating the x, I made this step a lot easier for myself. So now we have the absolute value of x times the limit as n approaches infinity of the absolute value of n over n plus 1. So you'll notice if we plug in n, we're going to get infinity over infinity, which is an indeterminate form, so we're going to need to use L'Hopital's rule. So by using L'Hopital's rule, we're going to take the derivative of the top and the bottom, and so now we're going to have the absolute value of x times the limit as n approaches infinity of 1 over 1, which is the absolute value of x times 1, which is simply the absolute value of x.
At x equals negative 1, we would plug in negative 1 for x. So that would give you negative 1 to the n over n. I've worked out the first three terms for you. As you can see, it converges by the alternating series test. Every time you justify with the alternating series test, you must state, because the series alternates and decreases in magnitude to 0. Negative 1 converges, and so it would be included in our interval of convergence. Just remember, convergent closed.
Okay, to test at x equals 1, we're going to use the limit comparison test. The limit comparison test is basically the limit as n approaches infinity of b sub n over a sub n, where b sub n is a parent function and a sub n is the given function. Okay, when we plug in x equals 1, we're going to get the summation from 1 to infinity of 1 to the n over n, so that's our a sub n. And for b sub n, we're going to use the summation of 1 to infinity of 1 over n, which is divergent because it's the known harmonic series. Okay, so let's plug into our limit comparison test formula. So we get the limit as n approaches infinity of the absolute value of 1 to the n over n times n over 1. As you can see, the n's are going to cancel, leaving us with the limit as n approaches infinity of 1 to the n over 1, which is going to equal infinity. And since we know that b sub n is divergent, and the result of the limit comparison test was divergent, then we guaranteed know that a sub n is going to be divergent. Therefore, x equals 1 is not included on the interval, so this is going to stay open.
After 5 long minutes of watching this video, we finally arrived to our conclusion that negative 1 is less than or equal to x, which is less than 1. This is Taney reporting live. Back to you, Heather.
Good luck on your AP exam!
Bloopers!